We are told to use the rules for exponents to simplify this expression and put the answer in exponential form. So let's look at the rules for exponents. There's the product rule. If we're multiplying like bases, add exponents. The zero exponent rule, any value to the zero power is 1. The negative exponent rule, if you have a negative exponent, cross the fraction bar and it'll be positive. Quotient rule, if you're dividing like bases, subtract the exponents. And now this looks like one we're going to use, the power rule. If you're raising a power to a power, you multiply the exponents. That's power rule A. Power rule B, if you have a product raised to a power, then each factor within the product is raised to that power. I think that's all that we'll use on this one. So how is this a product raised to a power? Well, if you look at what's inside the parentheses, you've got negative 2 to the 6th. The negative is not to the 6th power. Only the 2 is. However, then all of that is squared. So the negative is squared. It will be easier to see it if I rewrite this as negative 1 times 2 to the 6th, all squared. Alright, so now I apply the square to each factor, so I have negative 1 squared, 2 to the 6th squared. Alright, negative 1 times negative 1 is positive 1, so that's just positive. And, well, I'm going to put the 1, times 2, alright, raising a power to a power, multiply 6 times 2 is 12. So I have 1 times 2 to the 12th, or just 2 to the 12th. Okay, so that solves that one. Now let's go generally. If I'm raising a negative to an odd power, it's going to stay negative. If I'm raising a negative to an even power, it's going to be positive. Now you don't have to put the negative 1 if you don't want to. You can just say, you know, a negative to an even power is positive, so it's positive 2 to the 12th.